Okay, folks, we're gonna actually tear one of these guys apart, and I don't really want you to try this at home or do it on your system. So I got one of these older drives out here, and we're gonna see how this what's inside of a hard drive. First of all, they're so tightly sealed, they're dust-free. They're, I mean, as you can see, they look like armored cars, armored boxes, and that's for a reason. We don't want to have any dust on here because they spin at high resolution revolutions per minute. I mean, some of them are 3,000, some of them are up to 10,000 RPMs, and that's quite fast. Some of our cars only run at 3,500 RPM, so imagine a drive running at 10,000. They are very quick. They do not want any dust in there, so we want to keep them sealed. And if you actually open these up, the manufacturer, well, here we go, manufacturer's warranty's history, but we're going to do a test anyway. As you can see right here, this is absolutely amazing how it looks inside. Many of you have probably never seen this. And this is actually the platters. As you can see, they spin. And here I am destroying the drive. Now, this has actually been used and abused, so it's okay for me to touch it now. This actually uses something called a stepper motor, and I'll show you in a minute when I crank it up. It actually goes through miniature little steps here to find the data in the area slowly. And these are the platters right here. And it is sealed tight all the way around here. As you can see, very tight. I had to pry this open. So it's armored. I mean, you can this is all metal, aluminum all the way around here, very tight. And you can see the data cables back here. Here's the power cable connected. And I'm actually going to crank this guy up. So I'm going to stand back a little bit and just crank it up. Let's see how it looks. Let me go right here. Let me slowly put it up. Let me actually bring it up so you can see it a little better. You can focus in there a little bit. And let's crank this up. Let's bring this power supply here. I'm going to bring this back up here. Okay. Here we go. And I'm going to crank this guy up. Let me hold it up. And here we go. Check this out, folks. This is amazing. And you're going to see he's going to first crank up the high speed, maybe 3,000 RPMs. And look at this. Look at the stepper motor. Here he goes. Isn't that incredible? Look at that. Very high speed component. I mean, these are kind of the older systems, and boom, goes over and kind of parks itself on the corner. One of the problems with these drives, though, they never wanted to park themselves. So we had to go in there and just actually use some software to park the drive. Well, why do we want to park the drive? Well, we want to park the drive so that the actual heads are off the platters. We don't want to destroy any data. I mean, we bounce any of this stuff. Just to have an idea, the head and the platters are closer together than a little piece of hair. So, I mean, even a fingerprint almost can damage this. So even a dust bit will just fall on here and destroy the actual data on here. So we want to keep this very sealed up. Do not try this at home unless you want to get rid of your hard drive, and quickly. So I'm going to shut it down. Maybe we'll do another one of these real quick and bring it back up. There we go. I've cranked it back up. It's revving up the speed, 3,000 RPMs. So it's quite fast. And here he goes. I know many of you are just saying, wow, this is incredible. Yes, we hardly ever get a chance to see this. So this is what's happening actually inside the hard drive. Shut it off here. There we go. And this is one of the older models. It's still spinning. Okay, now we have a little bit newer model over here of an IDE. And I've actually opened this one up. I'm not going to crank it up, but I will show you what's inside. This is actually connected to the motherboard. As you can see, here's an enhanced IDE drive, and I've actually connected it straight to the motherboard. This is an integrated motherboard in here, as you can see, and I've physically put the cable in there. It's very nice, very easy to put in. There we go. We'll do it again. And we want to make sure that you read on the motherboard when you connect this that there's a little 1, and we know that the 1 and the red go together. So we know 1 and red go together here, so make sure you don't make that mistake. It's not going to, actually the drive will not come up and it won't be detected by the BIOS. If we come back here, we can see this is an IDE. Here's the actual controller. As we talked about, the actual controller is on the back of the drive. Come in here and physically the controller is on here, so it's very close to the hard drive. And one of the features that does is it lowers the noise, because there's noise in this area. I mean, inside the PC, there's a lot of noise and a lot of interference. So if we can keep the controller close to the drive, we have very little interference. We can speed up the drive. We can get a lot more data through there. And here we go. I'm going to open this guy up. See, it's very tight. Now, this is one of the newer drives. As you can see, it's a lot smaller, and there's only one platter here. I don't know if you can kind of focus in here. Sorry about that. We can focus in here. We can see only one platter. Okay, and it's kind of the same thing here, but there's a little difference in here. This uses a voice coil, what we call voice coil. This uses a stepper motor. And the voice coil, when we apply power to it, it cranks up. But when we let go of that power, it's kind of like a speaker. Your home speaker, boom, just shuts off, and it's self-parking, which was excellent, and it was a lot more precise. So the newer drives use voice coil, which is much better. As you can see, this is very simple to connect. And if we had a second drive, we'd actually use this cable, connect the second drive. And if we had more drives, we connect up to 4 with Enhance IDE. So it's very simple. As you can see, hard drives are nothing to it. You just got to remember that they are a piece of media. I mean, this is media that we're going to use every day. Some of them are fixed, like we're showing here. And we have also another one I want to bring out here at the last minute, which is called a zip drive. Let me bring this up to the table. This is a removable drive, which is amazing that they've brought this out. And this is actually, I'm going to pop this out, and this is actually a hard drive that's removable. This is not a floppy, folks. This is actually a 100 megabyte hard drive. So it's removable. We can pop it in here. Let me do that again for you. And it's actually running just like we do this. We pop it out, and here it goes, pops out. And this is actually a full-fledged hard drive. Same technology as this. The platters are right in here, the same. We got actually the needles just reading this, the same type of scenario. And I've even seen some of these that are bigger. Now they're even coming out with 2 gigabytes. And I just recently heard they came out with something called Click, which is absolutely the size of a matchbox. So they're going to even be put into little notebooks and so forth in the PCMCI slot. So these are going to, removable hard drives are here to stay. They're growing, and we need them because fixed drives, we have to leave them behind. We want to carry this with us, put it in our pocket, and they hold a lot more than floppies. I mean, floppies are only 1 megabyte, 1.4 megs. These hold 100 megabytes, quite a bit more. So this is the new zip drive. So as you can see, there's quite a lot of technology here. There's been quite a lot of advancement, and I want to let you know that for the test, we want to know all the interfaces, ST506. We want to cover SD. We want to go through EIDE. We want to talk about what the differences are among them, how much faster they are, what's been going on with this, how has the technology changed, even removable drives that we see now. Now, folks, there's a lot of technology here. Like I said before, get out your index cards. Put the different interfaces in there, the different type of drives. If you want to know about geometry, take a look at the slides and see what the difference is between the tracks, the sectors, cylinders, the heads. What is the difference? Why does that come into play? It's very important on this exam. I want to make sure you fully understand this.